And we're back for part 2. Example 3, if f of t is the velocity in an f of t per minute, feet per minute, with t in minutes, what are the units of the integral? Well, that we're going to have f of t is feet per minute, and dt is in minutes, so we would cross those out, and the units are going to be feet. So let's take a look at another example. Here we go. So we have f of t represents the bacteria population. It's 5 million at t equals 0. So in other words, we can say f of 0 equals 5. After t hours, the population is growing at an instantaneous rate of 2 to the t million bacteria per hour, meaning that we have f prime, or 2 to the t right there in million bacteria per hour, estimate the total increase in the bacteria population during the first hour and the population at t equals 1. So we're going to use the fundamental theorem, pretty awesome stuff, that we're looking for the change, f of 1 minus f of 0, and that means that I could write the integral from 0 to 1 of 2 to the t dt. Okay, so first, when I type this integral into the calculator, I'm going to end up with 1.443 million. Okay, and then let me move my board here. There we go. We already know that we have f of 0 is the 5. So I add the 5 over. So at year 1, we would have 6.443 million bacteria, and the rate that we'd have the change there would be the 1.443. Now this next one is an example that we're going to look at and kind of discuss that your answers could be a little bit different depending on how you look at it, but basically we have the rate that people are arriving to the theater, and we know that each hour, once the window is open, we're going to process 200 people per hour. Okay, the first people arrive at 8 and the ticket window does not open till 9. So those are the big things we have to check out with that. So we'll be flipping. Let me just make a dual screen. Maybe. Okay. So here's the questions. So it first says the length of the line at 9 a.m. So that means we're just looking at this section right here, the area under the curve. So from 8 to 9, we have, looks like almost the full 100, right? 1 hour by 100 people entering. And we can see that tiny little part right here is missing, but I would say it's made up in there. That's a little over half. So I'm going to guesstimate about 160. Move that right up there. So now at 10 a.m., we're going to be looking at this section all through here. So I already have the 160. And then I'm going to add on 100, 200. That looks like a little less than half, so 240. Add 240 onto that. And then I'm going to subtract, in that first hour, 200 were served. So that means we have approximately 200 people in line. So I want you to take a look at the rest of those questions, and I'll explain any of them that you need me to. So now we're going to use the definition of the definite integral, and we're going to figure out the average value, and really what that is 1 over b minus a times the integral of a to b of f of x dx, and really that's the average, just talking about the sum, the area under the curve, divided by how many. So looking at example 6 right here, all right, we have a function right here, p. We also know what we're going to do, predict the average population between the year 2000 and the year 20,000. Since we're working since 1980, that becomes t sub 0. 2000 becomes t sub 20, and 2020 becomes t equals 40. So when I write my integral, I'm going to say 1 over b minus a, 40 minus 20, go to the integral from 20 to 40 of the function. So then I'm going to type that integral in using this function right here. I'm going to have 1/20 times the 2942.66, and that's going to come out to be 147.1 million is our average between 2000 and 2020. So there's one more example for you to try. And when you go through and find the average value from -2 to 4, you can see the integral's already set up. You're going to end up with an answer of 72. Have a great night.